Doesn't work. Doesn't work. How do we? I'll load it up and then you can have a look at it in your own time. Okay. If you can't see it, then please let me know. Then I'll stop this straight away. Anyway. How do we prove this? How do we prove that this is a good result to have, isn't it? This is a very good result to have. I would twist the video towards you, but I've got to have your permission to say something like, but I can't. How do we prove? Why is this a good useful? Why is it useful to have the order k divides phi n? Why is that a good useful result to have? Sorry. Yeah. Well. Phi n you've got to work out. Okay. Once you worked out phi n, then what? What can you say about the order? It's a thing I said. If you've got two, if you've got 2 to the power of something, 2 to the power of whatever is congruent to 1 mod 1,000,001, and you want to work out k. I'm saying at the moment all I've got k is 1, 2, 3, 4, all the way to a million. I've got to go, don't I? Yeah. Yeah, k is a factor of phi n, isn't it? Yeah. That's what this is a good result to have, isn't it? This is a very good result because what you do know, once you've worked out phi n, it's going to be a factor of that. It's going to be one of those. It's not going to be anything else. Okay, so how do we prove this? How do we prove this result? How do we prove that, k divides phi n? How would you prove this? Any clues? We'll keep it closer because the order's in there as well, you see. How do we do this? Come on. What was the last result? Look at the last result we had. The last result we had, okay, it said, where is it? This is what it said. It said, the order, okay, let A have the order k, then a to the k is come to 1 if and only if k divides h, doesn't it? That's what it said, k divides h. We want to use that. Corollary means it's a step after the main theorem. So how do we prove that k divides phi n? Sorry? Yeah, because we know by Euler's theorem, we have a to the phi n. A to phi n is what? Yeah, that's congruent to 1 mod n. We know that, don't we? Yeah, we definitely know that. Okay, so since we know that, what can we say? We like I say, we want to use this. We want to use this result here. A to the h is come to 1 mod n if and only if k divides h. Yeah, h is equal to phi n, isn't it? Yeah, because a to the h is congruent to 1, isn't it? Yeah. Let h equal phi n. Let h equal phi n. Therefore, by the previous proposition, we have k divides phi n, don't we? Yeah, and that's it. So all you've got to do is look at the factors of All you've got to do is look at the factors of phi n. You work out phi n. So in order to find the order, instead of going 2 to the 1, 2 squared, 2 cubed, 2 all the way down, okay, all you've got to do is find the factors of 2 to the phi n. And just look at those, just check those. Don't check anything else. No, where you waste your time. If 9 is not a factor of phi n, there's no point taking 2 to the 9 or a to the 9 or whatever. You waste your time. Okay, so let's have let's find the order. Find the order of 2 modulo 13. Find the order of 2 mod 13. So how do we find this order? Sorry, we've done that one, haven't we? We've done 13. Sorry, 17. 17. Let's do 17. I know we've done that one. What do you know about 17? It's prime. So what's phi of 17? 16. Yeah, since 17 is prime, phi of 17 is clearly 17 minus 1, which is 16. Okay, equals 16. So, what's going to be the order? How are we going to work out the order? What can the order possibly be? Or what can't it be? What should you look for? Where should you search to find the order? Yeah, factors of 16, yeah? The factors of 16. The factors of 16 are 2, no, well, the 1, 2, what else? 4, yep. 4, yep. 8, and 16 itself, isn't it, yeah? Okay, so we look at, so that's what you're going to check, don't you? These indices, yeah? 2 to the 1 gives you what? 2, yeah? 2 squared. Modulo 17, 4, yeah? No good checking. Why don't we check 2 to the 3? That's what I would have done in the first hour, wouldn't I? Why ain't I checking 2 to the 3? Yes, it ain't going to be it. Why ain't it going to be it? Sorry? No, it's not already there. It's not divisor 16. Yeah, 3 doesn't go into 16. Okay? 3 is definitely going to be, there's no point looking at 3 because 3 is not a factor of 16. So the only other one that can be is 2 to the 4. What is that? What's 2 to the 4? Come on, you should know 2 to the 4. No, yeah, 16. Is that it? Minus 1. Yeah, that's coming to minus 1, isn't it? We're dealing with modulo 17, aren't we? Yeah? Because we don't want minus 1, we want plus 1, don't we? Minus 1 is a good result to have anyway, but we want plus 1, yeah? So, what's it going to be? 2 to the 8. 2 to the 8 is what? What's 2 to the 8? Sorry? No, I wouldn't even do that. Much easier than that. You must be right. It is 256. I'm not disputing that.
Minus 1 squared.
Sorry?
Will be, well, 2 to the 4 squared or minus 1 squared.
Exactly. That's where you want to do it. 2 to the 4 all squared, which is minus 1 all squared, which is 1 modulo 17. That's the way to do, that's the way you want to do that. Not, you can do that a long way. I'm not saying you can't, but, this is much better to do that. Okay, so what's the order? What's the order of 2 modulo 17? Yeah, the order of 2 mod 17 is 8. Okay, it is definitely 8. It's so much easier to do that, isn't it, than trying to, work out all the 2 to the 1, 2 squared, 2 cubed, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 8. You don't want to do that. We're wasting your time doing that. Okay, find the order of, let's do another example. Find the order of 3 mod 13. How do we find the order of 3 mod 13? Sorry? 5, yeah, 13 is a prime again, isn't it? Yeah? Since 13 is prime, we have phi of 13 is 12. Okay? Sorry? Yeah, the factors of 12. The factors of 12, the divisor. We know that the order is going to be a factor of 12, don't we? We know that. Okay, because it's the order is given by a divisor of phi n, and phi n is, or phi 13 is 12 in this case. So the factors, what are the factors of 12? Yep, it's 12, 12 are 1, 2, go ahead. 3, 4, yep. 6 and 12 itself, yeah? Okay, so we were going to work out, not all of them, just those ones. Those are all the indices we need to work through, don't we, yeah? So 2 to the 1 gives you 2, that's no good. 2 squared is 4. 2 cubed is 8, yeah?
It's not meant to be 3.
Oh, sorry, yeah. Sorry, it should be 3. 3, sorry, not 2, it should be 3. When dealing with it, there's the question, 3. Okay, 3 to the 1 is 3. 3 squared is what? 9, yep. 3 cubed is 27 or, well, yeah, 27 would be okay. Well, I was going to do it, yeah, which is 1, isn't it? Yeah, which is 1, 27, okay, which is congruent to 1 modulo 13. Yeah, 27, because 26 is a factor of 26 is 13 times 2. So what's the order? The order is the order of 3 mod 13 is what? Yeah, it's 3, yeah? It's 3. Find the order of 2 modulo 13 now. Find the order of 2 modulo 13. Of 2 mod 13. Please do attend these lectures. I'm not going to make a habit of doing this. I just want to try this out. I do this with engineers and see if it works or not. I don't want students missing these lectures. They've been videoed. And if you don't like them, you can say so. I've got no... How do we find the order of 2 modulo 13? What's it going to be? It's going to be a factor of 12, isn't it? Yeah? Okay. So the order will be a factor of 12, which is again 1, 2, 3, 4, 6, and 12. Okay. So now we're going to go through them, don't we? Yeah? We're going to go through this. So it's 2 to the 1. 2 squared. What's 2 to the 1? 2, yeah, 2 squared, 4, 2 to the 3 is 8, we're doing modulo 13, yeah, 2 to the 4, yeah, which is 3 modulo 13, isn't it, yeah, the 16, you're quite right, 3, 2 to the 4, what else do I need, 2 to the 5? Sorry? You don't need to do it, do you? 2 to the 5 was a decoy question by me. You don't need 2 to the 5, do you? Wasting your time doing. You can do it if you want, but I wasn't trying to catch you out, Maurice. But you don't need 2 to the 5 simply because it's 1, 2, 3, 4. No 5 there. All one is 2 to the 6, don't we? Yeah. 2 to the 6, which is you either know it or you can write it as 2, 3 squared, can't you? Yeah. Which is 8 squared, which is 64. And what's that? Modulo 13. Sorry? Well done, minus 1, it'll be 65. I know is a multiple, that's minus 1 modulo 13. Okay? So you can either, hang on now, where are we? We've got a 2 to the 6. You can either say, stop here and be very clever and say what? Be very smart about this. It's going to be 2 to the 12. There's no other choice, is there? There's only one factor left. It's the last one. And also, when you minus 1, when you square that up, yeah? When you square that up, you go 1, don't you? Okay, so you can either check it or you can stop there if you want. You can say, hang on, there's none of the factors before. We know 2 to the 12 is. It's got to be. By Euler's theorem, we know that's going to be 1. That's chapter 5 work. Okay? So we don't need to check that if you don't want to. So you can either stop here and say the order is 12, or if you want to make sure you don't need to, but if you're lacking confidence or whatever, you can say by Euler, you can say the order is 12. Okay? 2 to the 12 is common to 1 mod 13. The order is the order, hang on, of 2 mod 13 is 12. So it might not come, it might be the last one. Don't assume it's always going to be, you know, one of the earlier ones. It may not be, it may be, it may not be. Okay. Let me move on to something else. Oh, you can't see this. All right. It'll come on, don't worry. Hopefully it will. If it won't, I'll have to... Come on. It's gone to sleep. That's what I think about this technology.